I am Anil Kumar. Welcome to my series on advanced functions. Here is a test paper on Unit 1. This is a prerequisite for calculus. We'll have 15 questions in this test paper. First, let us see what the questions are and then we'll provide their solutions. Question number 1. Find a parent function which is always decreasing in its domain. Question number 2. Write a function with domain x belongs to real numbers, which is both even and odd. Justify your answer. Well, this is a very important question seen many times in the test paper, and there's only one function which meets this criteria. Question number 3. Describe two similarities and two differences for a given set of functions. F of x equals to x and g of x equals to 1 over x, and f of x equals to x squared and g of x is equal to absolute value of x. Question number 4. Write domain and range of f of x equals to x minus 1 whole square plus y plus 2 whole square equals to 4. Question number 5. Write increasing interval for f of x equals to sine x. You should provide the general solution, right? Question number 6. Describe end behavior of g of x equals to x plus 2 divided by x plus 1. End behavior is what happens when x approaches positive infinity and what happens when x approaches negative infinity. Question number 7. Determine the image of 4, 6 after it is transformed through y equals to 4 of f times 1 over 3x plus 6 within brackets minus 3. Question 8. Determine the equation of inverse of f of x equals to 2 minus 4 square root x plus 5 divided by 3. Write domain and range of the inverse. Question number 9. Express the following using absolute value notation. X is greater than minus 5 and less than 7, and then we have b, which is x belongs to real numbers where x is not equal to 5. Question number 10. Determine whether each function is even, odd, or neither. F of x equals to x cubed plus x squared plus 1. B. F of x equals to x minus sine x. Question number 11. A certain income tax system takes 1% of the first 5,000 made, 20% of the next 30,000 and 40% of the rest. Write a piecewise function to model the amount of taxes paid according to income. Use your equation to calculate the tax for annual salary of 80,000. Question number 12. Determine the value of a and b that would make the following function continuous. So as a piecewise function, f of x equals to minus x minus 5 for x less than minus 3.5. F of x equals to half of ax plus 2 for x between minus 3.5 and 2, both included. And when x is greater than 2, f of x is 4bx. The last 4 questions now are: graph the function 2 to the power of absolute value of x minus 2 plus 1. Describe 5 characteristics of this function. Question 14. Express circumference of a circle as a function of its area. Question 15. Determine the function gf if f of x equals to minus 1, 2, 0, 5, 1, 0, 2, 1. So 4 points are given on f of x, and g of x is square root of x minus 1. Question 16. The graph of y equals to square root of x is reflected on the y-axis, is horizontally stretched by a factor of 2, shifted 3 units up and 1 unit left. Write the equation of the transformed graph. So I hope you find them interesting. You can now pause the video, answer them one by one. Now let us look into these solutions one by one. Question number 1. Write a parent function which is always decreasing in its domain. Well, the function is f of x equals to 1 over x. Now, if you see the graph of this function, what do you notice? The graph of this function is always decreasing, right? On the side, when x is less than 0, it is decreasing from almost 0 towards the negative value. And in first quadrant, it is decreasing from infinitely large values to 0, right? So this function 1 over x is always decreasing in its domain, and the domain does not include 0. Clear? Question number 2. Write a function with domain x belongs to real numbers, which is both even and odd. Justify your function. This function is an odd function, it's symmetric about 0. Now we're talking about a function which is both even and odd. So when it is both even and odd, it has to be symmetric about the y-axis and also the point, right? What could be the function? Well, here is your function. The x-axis itself is symmetric about both. And what is the equation of this? Well, the equation of this is f of x is equal to 0, right? So the y value is equal to 0. So that is the function. Perfect. Question number 3. Describe two similarities and two differences for the given set of functions. So when we're talking about a line and 1 over x, so what could be two similarities and two differences? So let me just sketch a function in short here. So these are two functions, f of x equals to x, which is the straight line, correct? So that is your function f of x equals to x, and the other function is 1 over x, which we have already drawn, but let me draw it here once again just to show you the differences, right? So these are the two functions we're talking about. So what do you think are the similarities between these two? Well, similarity, let's write down similarities. How are they similar? 1, both have odd symmetry. Correct? So both are symmetric about the origin. That is one similarity which they have. And the second similarity, you can see that they are both are in quadrant 3 and in quadrant 1. So they are in quadrant 3 and in quadrant 1. So that is also a similarity. So these are the similarities which you could write about these functions. Now, what are the differences? Now, there are many differences, so you could list. So let's write down the differences now. We have to give two differences. One difference could be that the function straight line is always increasing, right? So we say f of x is increasing, and 1 over x, I should say x is increasing, and 1 over x is decreasing, correct? So f of x, which is a straight line, is increasing. G of x, which is 1 over x, is always decreasing in the domain. That is one difference. Second difference we can say about the end behavior. Right, so these are good differences. For f of x, we can say when x approaches minus infinity, y approaches minus infinity, right? So that is f of x. And when x approaches positive infinity, y approaches positive infinity. That is f of x. And for g of x, when x approaches positive or negative infinity, y approaches 0, right? So there is g of x, which is approaching 0 as x approaches positive or negative infinity, correct? So these are good differences between the two functions. Now let's look into the other two. That set is also very common. We are now looking into x square and absolute value of x. So x square is a function which is a parabola which turns and it's a smooth curve, right? And absolute value of x is something like this, which is a straight line. So as far as the similarities are concerned, we can write many similarities here, right? So let's list two of them. One of them is that they are in quadrant 2 to quadrant 1, right? So that is similar to. The similarity between these two functions is decreasing and increasing interval, right? So same decreasing and increasing interval, right? So they decrease when x is from minus infinity to 0, and both of them increase from 0 to infinity. Okay? So these are two similarities. Now we can write their differences. Well, difference here is that the rate of change is for parabola, for f of x, is always decreasing, always increasing. For x square, right? And here it is constant. So basically rate of change is always decreasing. You see, if you draw a tangent line, then it has a negative slope, 0 and positive. But if you have rate of change for absolute function, in that case you notice that it is constant in the first half, undefined, and again positive. So it is constant. It is minus 1, and then it is plus 1. So constant. Minus 1 when x is less than 0, and plus 1 when x is greater than 0. Correct? At this point, it is undefined. So let me take this as a second difference. Okay. So the second difference is that at 0, x square is smooth curve, but absolute x is corner, right? So here the slope is not defined, right? And absolute x is a corner at this point at 0, correct? So that could be the second difference between these two. So now I hope you can see it clearly. Let's move on and take the question number 4. Question number 4 is, write domain range of f of x equals to x minus 1 whole square plus y plus 2 whole square equals to 4. So this is a circle which is not a function, right? So clearly, so we're talking about a circle which is not a function. So what is its domain and range? So let me sketch one here. The radius of this circle is 4, right? So the radius is 4. And the point, which is the center of the circle, has moved to 1 minus 2. So this point here is 1 minus 2. Correct? So that is the circle which we're talking about. Correct? So if you see, let me sketch this. So at 1 it has gone down, so kind of, let's say this is x-axis, I'll use different colors here anyway, and that is the y-axis, correct? So what you notice here as far as the domain range is concerned, so if you look at this point, it goes 4 to the right, but it has already moved 1 unit to the right. So the domain is up to 5. On the left side, it goes 4 and shifted 1 unit to the right. So it is from 3 to 5, correct? So we can write here that the domain of this function, it is not a function, I'm sorry, domain of this function, again, the domain of this relation is x belongs to real numbers, where x is from minus, so it moved 4 units and then 1, so minus 3 to 5, correct? As far as the range is concerned, for this relation y belongs to real numbers, it goes 4 up but 2 minus, that means 2 up, right? And as far as down is concerned, minus 6. So it's from minus 6 to 2. So that is the domain and range for the circle, which is a relation, right? Question 5. Write increasing interval for sine x. Now, the sine x graph will be something like this. Let me sketch it here. So let me just make one wave here. Okay. So it's kind of repeats, right? Now, when we talk about increasing interval, this is the interval in which the sine x is increasing. So this point here is minus 90, and the top, which is when the sine function is 1, is plus 90, correct? So the increasing interval is from minus 90 to plus 90 in one cycle. And we know that the time period t is 360 degrees, right? Is 360 degrees. So we can say that the increasing interval is from what? Is from minus 90 plus, it repeats after every cycle, 360n to plus 90 plus 360n, right? Now, to write a general expression, I can take 90 common. So when I take 90 common, it becomes from, this becomes minus 1, this is 4n, right? So we can write this as 4n minus 1, and here we can write this as 4n plus 1. Is that clear to you? So that becomes the increasing interval in degrees, where n belongs to integers, right? So it repeats after every cycle. So that is how we can answer question number 5. So I hope the concept is clear. Let's move on and take the next set of questions, 6 and 7. I'd like you to pause the video at this stage, answer these questions, and then look into my suggestions. Question number 6. Describe end behavior of g of x equals to x plus 2 over x plus 1. Well, sometimes we can rewrite this function to see the end behavior. See how we can do it. X plus 2 over x plus 1, I could write this as x plus 1, right? That is x plus 2 over x plus 1. Now, so that is equal to x plus 1 over x plus 1 plus 1 over x plus 1, correct? So this is what? Now here we can write g of x as equal to, that is 1 plus 1 over x plus 1, 1 over x plus 1, clear? So from here we can very easily say that when x approaches negative infinity, in that case y approaches 1, correct? Because this term 1 over x plus 1 approaches 0. If x is very large, it could be very large positive value or negative value, right? So if it is kind of a negative very large value, we are taking away something from 1, so it approaches 1 from the negative side. So that could be a better answer. Now when x approaches positive infinity, y again approaches 1, but this time we are adding something, right? Maybe very small, so it is approaching 1 from the positive side. So this is one way of answering it, right? The other way of answering this is that we can actually factor out x. So we have g of x equals to x times 1 plus 2 over x over x times 1 plus 1 over x. So factoring x. So now you could cancel this x, and what you're left with is 1 plus 2 over x and 1 plus 1 over x. Now when x is approaching positive or negative infinity, this function is approaching 1. Do you see that? This term here, when x is approaching positive or negative infinity, 2 over x or 1 over x approaches 0. Right? So this term approaches 0. We are left with, as x approaches positive or negative infinity, g of x approaches this value of 1. Right? So whenever you're given a rational function with the same degree, it is the leading coefficients of numerator and denominator, which is the horizontal asymptote. Right? So remember one thing, that in such cases, horizontal asymptote is ratio of leading coefficients of numerator and denominator. Clear? So that is how you could easily answer this question. Now let's look into question number 7. Determine the image of 4, 6, the point 4, 6, after it is transformed through y equals to 4 f of 1 over 3x plus 6 minus 3. So let's rewrite this. We could actually take 1 over 3 common. So I'll write this as 4 f of, taking 1 over 3 common, 3, we get x, and that becomes 18, right? So x plus 18 minus 3. Now when that is your function, you can now write down the transformations. A point xy on original function will now get transformed. The x value will get multiplied by 3, right? So it is a horizontal stretch by a factor of 3, and move 18 units left, minus 18. As far as the y point is concerned, it will get multiplied by 4 and will move 3 units down. So 4 times the y value, minus 3, right? So that is how the coordinates will change. Now we are talking about the coordinates 4 and 6, right? So if x is 4, y is 6, in that case the image of this particular point will be what? So we'll just multiply 3 with 4, then take away 18. As far as y is concerned, we'll multiply by 6, 4, and then take away 3. And what we get here is 12 minus 18, which is minus 6, right? And here we get 24 minus 3, which is 21. So that becomes the image, right? Therefore, image is minus 621. Clear? So that is how you're going to answer question number 7. Question number 8. Determine the inverse of this function. So we are given the function here, which is f of x equals to, let me rewrite this as minus 4 square root, now that function, square root 1 over 3 for x plus 5, right? Okay. So as far as the function is concerned, see, it is a function which domain and range is restricted, right? So what we have here is the domain of this particular function is that x value belongs to real numbers. However, x value should be greater than equal to minus 5, right? So x is greater than equal to minus 5. As far as the range of this function is concerned, y value belongs to real numbers, and that is a reflection on the x-axis, so it is always decreasing, right? I'm sorry, plus 2 here. Okay, it is always decreasing and decreasing from the value 2. So it is always y is less than equal to 2. So that is the function, right? Remember this, and that helps us to find the domain and range of the inverse, right? So we can, from here, we can write domain of inverse. Let me write f inverse x will be what? The domain will be this, because they will flip, right? So the domain of this inverse of the function will be that y is, domain is x will be less than equal to 2, correct? That is going to be the domain. And as far as the range is concerned of the inverse will be a function in this case, right? As far as the range is concerned, so the y will be greater than or equal to -5, correct? And of course, x belongs to real numbers and y belongs to real numbers. Is that correct? So that is the answer for part B, right? So to get the answer, it is better to first write down the domain and range of the function itself and then kind of change it, right? Inverse means you have to interchange x and y values. Perfect. Okay, now let's get back to finding inverse itself. So to find inverse, we have to swap, right? So what we get here is we get x equals to 2 minus 4 square root, and then we have y plus 5 over 3, correct? We have to isolate y now. So first thing is we'll add 2. So we get x, subtract 2 rather, x minus 2 equals to minus 4 square root of y plus 5 over 3. Now we have to divide by minus 4. So we get x minus 2 divided by minus 4 equals to square root of y plus 5 over 3. Correct? Now, in this particular function, we have to now square both sides. So let me rewrite this. Well, let's keep it like this itself, and then we can change this. What I'm trying to say is this is negative sign, so we can take 2 minus x also. We could do that. Anyway, let's keep it like this. So we have x minus 2 over minus 4 whole square. And here we have y plus 5 over 3. Now, we have to multiply by 3 all this x minus 2 over minus 4 whole square. And then I have less space here, so I'll just take away 5 equals to y. Now, if you leave your answer in this form, then you actually get a wrong answer. You will notice that this is a parabola, right? However, you know the domain is restricted. X has to be less than or equal to 2. So when you do this step, when you square rather, at this stage, it is kind of important to write that x is less than or equal to 2, right? So that is a very, very important point, correct? Here we are only considering the negative part of it, right? Not both positive and negative. Right? So that is kind of important. And so we can write that the f inverse of x is basically equal to 3 times. You could change this minus, and you could write this as, okay. So you can say minus 1 over 4, okay. X minus 2, it makes more sense to keep it like this, minus 5. Now it is kind of very important to understand the reflection part of the parabola also, and also we have that x is less than or equal to 2. Now this is kind of important to write. So once you have this, then you're correctly defining your inverse function, and this becomes your domain and range. So let's say this is part A and this is part B. So that is part A and this is part B for us. We have written domain range first. However, it's very clear from here, unless and until you write that x is less than or equal to 2, the answer is not complete, right? You will not get the domain which you wrote initially. Perfect. So now we have question number 9, which says, express the following using absolute value notation. Now, this one here on a number line, we are saying x is between minus 5 and 7. This set of values. How will you write this as an absolute function? Think about it. The other one here is on a number line. We are saying x is everything except for 5, right? So that's values 5, and all other values are the solutions, right? So except for 5. How will you write this as an absolute value function? Well, the method here is first to find the midpoint. Midpoint is add them, right? Divide by 2. So we get 2 divided by 2 as 1. So the midpoint here of this is at 1. Now from the midpoint, we have to see how far are we going, correct? So it is going 6 and minus 6. Do you see that? So now you can clearly write down the absolute function. The absolute function has moved 1 unit to the right, so that means x minus 1, and the value is less than 6. So that becomes your answer. Does it make sense to you? Correct? So that is how we are going to answer the first one. The second one here, you have to write this as an absolute function which does not include 5. So we can say that the solution of this, look at the solution. X, we move to 5, right? And we say this is greater than 0. So when I say this is greater than 0, we get all the points in real numbers except for 5, because at 5 it is equal to 0. Does make sense to you? So that is how you could quickly write down and get full marks in this particular question. Question number 10. Determine whether each function is even, odd, or neither. So to find even, odd, or neither, we could inspect and also say, we know here we have an even term and an odd term, so it's neither. Right? Since we have both even and odd terms. Now in this case, both of them are odd functions, so this function is odd function. Clear? However, let's prove it. Let's have algebraic solution. So how do you do that? To find the algebraic solution, we find what is f of minus x. So if I substitute x with minus x in the equation, what do I get? I get this, and then we get minus x cubed plus that becomes positive x squared plus 1. And if I take minus common, in that case we get x cubed minus x squared minus 1. So we see this is not equal to that. Perfect. And it is not the same as that also, and therefore we have neither. Now in the other question, let's do it. So here if I do f of minus x, I get minus x minus sine of minus x. Now that is minus x. Sine of minus x is negative, right? So we get positive sine x. Now if I take minus common, I get x minus sine x, correct? Which is same as minus of f of x. Now since f of minus x is same as minus of f of x, this is an odd function. It has odd symmetry, right? So that is how we could actually say, right? So this is neither, but this one is odd symmetry. Perfect. So that is how we could do it. Question number 11. This question number 11, which is very important application question. Says a certain income tax system takes 10%, this is not 1, 10% of the first 5,000 made, 20% of the next 30,000 and 40% of the rest. Write a piecewise function to model the amount of taxes paid according to the income. Right. So there are 3 slabs. So when the value of x is between 0, I mean you could include this, and less than equal to 5,000, in that case, it is only 10%. So in this interval, the tax rate T of x, we can say, is equal to 10%, means 10 over 100 of the x value. So I could write this as 0.1x. Clear? So that is the first interval. But when the value of x is from 5,000, we should not include it here, but up to 30,000, that will be included. Right? So higher the income, you should pay lower amount. So this is included in the lower amount. So in this case, the tax will be how much? Well, on the first 5,000, you made a tax of 1%, right? So it's kind of important to also calculate what is the maximum in this interval you pay, right? So maximum you pay will be when x is equal to 5,000, correct? So let's calculate. So that is equal to 0.1 times 5,000, which is 500, correct? So you pay 500 on the first 5,000 and balance you pay 20%. Does make sense to you? So the tax rate in this interval will be, you pay 500 on the first, right, and balance of 20%. That means 20% is 0.2, and that is what you pay on everything earned more than 5,000. And on the first 5,000, you have already paid 500. Does it make sense to you? That is how you create your equation, correct? So that is your second slab. Now, so we had this first one, the second one, and now if it is more than 30,000, that means the x value is more than 30,000. In that case, the tax bracket is increased, and now you are paying 40%. So it is 40%, which is 0.4, on the earnings more than 30,000, correct? Now, what was the maximum did you pay on this? So you need to calculate maximum here also. So let's do the calculation for max when x is equals to 30,000. So substituting 30,000 here, we get 0.2 times 30,000 minus 5,000, correct? Plus 500, which is equal to 0.2 times 25,000 plus 500, correct? So that is 5,500, correct? So we get 5,500. So this amount, we have already paid 5,500 here. So that is the amount which you pay, right? Sometimes it is also important to simplify these expressions. You could write like this also, or you could simplify them. So it's a good idea to even simplify these expressions and then write down your answers. So if I want to simplify this, I can write this as 0.4x minus 4 times 3 is 12, right? So we get minus 0.1 will decrease 1, so 12,000. Correct? So 12,000 plus 5,500. So when you take away, you get what? You get 0.4x minus 6,500, right? So taking away this much, you get 6,500. So that could be a simplified form. So you could actually write this in the simplified form also, right? Similarly, I could write simplified form here also. I could write this as equal to, let me just fill it up here with less space. We have 0.2x, and when I multiply this by 5,000, it becomes 5 times 2 as 10, and then 1 decimal goes. So 1,000, correct? So when we take away 1,000 from 500, we are left with minus 500. So we get minus 500. Clear? So well, that gives us the functions basically. So let me rewrite the answer here. So the tax rate now can be written as 3-piece function, right? So let me write 3-piece function. So the first piece here is 0.1x, And here x is between the interval from 0 to 5,000. Okay. The next x bracket is in the interval when x is between 5,000 to 30,000, and then the equation which we came up with is 0.2 x minus 500, and that is when x is from 5,000, x is greater than 5,000, but x is less than 30,000. I should have written in one line, but since there is less space, I'm writing like this. Okay. The last bracket here is 0.4x minus 6,500 when, so let's rewrite here, and this bracket is for x which is greater than, so 30,000 will be included in the second bracket, 30,000. So when x is greater than 30,000. Is it clear to you? So that is how we are going to write the tax rates. Now the second part of this question is find the tax for 80,000. So let's calculate. So 80,000 means last bracket, correct? So it is equal to 0.4 times 80,000 minus 6,500, correct? So 1 0 cancels, so we get 32,000 minus 6,500 using our simplified form, and when you do that you get this as equals to, so 2 zeros, and this will be 5 borrowed from 31 gives us 25, correct? So that is the so many dollars. So our answer is in dollars the tax will be 25,500. So that is how we are going to answer this question. I hope it makes sense. Here is question number 12, a piecewise function. We need to find the values of a and b, which can make this piecewise function a continuous function. So the question here is, determine the value of a and b that would make the following function continuous. F of x equals to minus x minus 5 for x less than minus 3.5, half of ax plus 2 for x between 3.5 and 2 minus 3.5, both included, and 4bx when x is greater than 2. So when we say that it has to be continuous, there are three pieces. The first piece and the second piece are joined at 3.5 negative, right? Negative 3.5. So at that point, we should have both the pieces joined together. So at x equals to negative 3.5, what is the value? So if I substitute on the first branch, which is minus of minus 3.5 minus 5, that should match with the second part. So here it is half of a times minus 3.5 plus 2. Right. So we have to find the value of a from here. That's what it means. So we have here 3.5 minus 5 equals to minus, this is negative, right? 3.5 over 2a plus 2. So that gives you minus 1.5. So we have minus 1.5. Taking 2 to this side, we get minus 2. Now that is equals to minus 3.5a over 2. So this is minus 3.5 also, right? So we'll cross multiply and find the value of a. So the value of a, let's do minus 3.5. That is minus 3.5. We're going to multiply this by 2, divide by minus 3.5 to get the value of a. So clearly we get a as equal to 2, right? So we get the value of a as 2. Now, the second part and the third part should match at x equals to 2. So at x equals to 2, we'll substitute 2 here. We already know a is also equal to 2, right? So that minus minus cancel. So a is 2. So if I substitute 2 here, we get half of x is 2. So 2a we can write, right? 2a plus 2. That should be equal to, substituting 2 for x, we get 4b times 2, right? Now we know a is 2 since we just calculated. So we'll substitute this value 2 here anyway. We can cancel this 2 first. So a plus 2, or we can write, since a equals to 2, we can write this as 2 plus 2 equals to 8b, right? So which is 4 divided by 8 is equal to b, or the value of b is half. So we get, for the function to be continuous, a should be equal to 2 and b should be equal to half. Is that clear to you? Correct? So now let's continue and take the other questions of this list. And here is question number 13. Graph the function f of x equals to 2 to the power of absolute value of x minus 2 plus 1. Describe 5 characteristics of this particular function. So 2 to the power of something which is an absolute value plus 1 is your function. You can always pause the video, answer this question, and then look into my suggestions. Now in such questions, I'll prefer that you create some table of values, right? So let's make a table of values here. So we'll have different values of x, and for that we are going to calculate the y values. So let's take some x values, and for each x value we'll calculate what is 2 to the power of absolute value of x minus 2 plus 1, correct? Okay, so let's begin with when x approaches minus infinity. So if x is very large value, then I get 2 to the power of infinity large plus 1. So we know this function is approaching positive infinity. Right? Similarly, we can also think about the end behavior. What happens when x approaches positive infinity? In that case also, we see it will be approaching positive infinity. So both sides up. So that is the end behavior, and now let's talk about the points in between. So if I take a value of x, let's say minus 2, then what do we get here? We get 2 to the power of minus 2 is minus 4. Absolute value will be positive always, right? So we have this, which is 16 plus 1 is 17. If I take minus 1, I get 2 to the power of minus 3. Absolute value is plus 3. Plus 1, which is 9. For 0, we get 2 to the power of 2 plus 1, which is 5. For 1, we get 2 to the power of 1 plus 1, which is 2 plus 1 is 3. For a value which is 2, 2 minus 2 is 0. So we get 2 to the power of 0 plus 1, which is 2. And then for 3, 3 minus 2 is 1. So we get 2 to the power of 1 plus 1, which is 3 again. And for 4, it will be 4 minus 2 as 2. So 2 square plus 1, which is 5. So you see these values are repeating. So for 5 will be 2 to the power of 3 plus 1, which is 9. Lowest being at 2, right? So that becomes your local minimum, correct? Now with these values, let me sketch the graph here, and then we are going to write down the characteristics. We see that all the values will be positive, right? Since it is 2 to the power, it is more like a parabola, which shifted 1 unit up, right? And symmetric about this particular point. So we could actually, we know that the minimum is at 2, at, let's say this is 2 for us, right? 2, 2. Then the graph will be kind of like this. You see that? So that is how it is going to be. And this value here will be 2, as we can see, and the y-intercept will be at 5 when x is 0. Is that clear to you? So that is how you could actually graph the function 2 to the power of absolute value of x minus 2 plus 1, correct? Now, let's do the second part and writing characteristics. So the first characteristics which I'm going to write here is the domain. So domain of the function is x belongs to real numbers, right? The second one is the range. So as far as the range is concerned, y belongs to real numbers. However, we see that the y value is always greater than or equal to 2. Correct? Now, end behavior. End behavior, as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y also approaches positive infinity. Then we could have increasing and decreasing interval, right? So let's write increasing interval. So it is increasing from 2 to infinity, correct? And then we can write decreasing interval. It is decreasing from minus infinity to 2. Okay? So that is how we could write different characteristics for this particular function. Okay? So I hope it makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best. Now here is question number 14, which says express circumference of a circle as a function of its area. So let's write down the two equations. When we are considering a circle, then in that case area is equal to pi r square and circumference is 2 pi r, correct? So these are the two relations. We want to express circumference of a circle. So let's call this circumference as C and area is A. So we want circumference as a function of area. So we know C is 2 pi r. Now to get this as a function of A, we can actually isolate r, right? So from this equation, we can work what r is in terms of A. So let's do that part first. So we get A is pi r square. So A by pi is basically r square. So square root of A by pi is basically equal to r. We have to take positive values since r is always greater than or equal to 0. So that becomes the value of r. So we can now write C as equals to 2 pi, the value in terms of A is square root A over pi, correct? So that means this is divided by square root of pi. So we could say this C is 2 times square root of A pi. Is it clear to you? So that becomes the relation. So we can say circumference as a function of area is equals to 2 times square root of pi is a constant, so it's better to write pi first. So that becomes our relation. Is that clear to you? Right? So if I equate, let me call this as equation 1, this as equation 2, we get this from equation 1 and 2. We substitute the value of r here to get our solution. Correct? So that's how you could do it. A test paper of unit 1. This is question number 15. Determine the function g times f if f of x equals to minus 1, 2, 0, 5, 1, 0, and 2, 1. So these are the 4 points on the function f of x. G of x is given to you as square root of x minus 1. You can always pause the video, answer this question, and then look into my suggestions. Well, let me first sketch this, and then we will discuss how to solve such questions, right? First thing to understand here is that when we write GF, it really means we are looking for a product of this, right? So that is like G times F, right? So outputs are going to be multiplied. Now that only helps, that only happens on the common domain, right? Now let's try to sketch the function. Let's say, let me sketch g of x first. G of x is given to us as square root of x minus 1. So that means at 1, the value will be 0, right? So let's say this is 1 for us. Let me make some scale. 1, 2, 3, 4, 5. And here we have 1, 2, 3, 4, 5, 6. So if I substitute x equals to 1, I get 0 here. So that is 1 point. If I substitute 2, then I get square root of 1, which is 1. So 3, 4, and if I substitute 5, 1, 1, 2, 3, 4, 5. 5 minus 1 is 4, and the square root will be 2, right? So I get this function kind of like this. So I could draw this function as this. So that is our g of x. Now let's look into the function f of x. So I'll sketch these 4 points using this greening, minus 1, 2. So at minus 1, we have a value 2. At 0, the value is 5. So at 0, it is 1, 2, 3, 4, and 1, 5. At 1, it is 0. So at 1, it is 0. At 2, it is 1. At 2, it is 1. Right? These are the values. Now clearly, you can see from here that these are the only 2 values which are in the same domain, right? So these are the only 2 points which can be multiplied, correct? So we could write g of f as equal to these 2 points. So when x is equal to, at this point, when x is equals to 1, the product 0 times 0 is basically 0. Right? The other point is when x is equals to 2, that is 1 times 1, right? So both get value of 1. So at 2, the answer is 1. Do you see that? So those are the solutions for this. The product of the function gf is basically these 2 points. Is that correct? Right? So that is how you could actually find the product of 2 functions. So I hope it is absolutely clear. So you can introduce more points and see how it changes. Okay. Now let's take up the last question, which is question number 16. The question here is, the graph of y equals to square root of x is reflected on the y-axis, is horizontally stretched by a factor of 2. Shift 3 units up and 1 unit left. Write the equation of the transformed function. So we are given the function y equals to square root of x. The transformations here are, first, reflected on y-axis. So if you reflect this on y-axis, then what do you get? You get this function as minus square root of x, correct? Horizontally stretched by a factor of 2. Second is horizontally by a factor of 2. That means inside this, right? So it becomes square root of half x. That's what it means, right? Then we have shifted 3 units up and 1 unit left. So we have 3 units up and we have 1 unit left. So when I say 3 units up, then it becomes, the function becomes minus half x. Up means 3 units, we have to add 3 outside. And 1 unit left means the function becomes minus half x. Now, 1 unit left means you have to put it in brackets plus 1. And you have this function. Is that clear to you? Correct? So, we can write that the transformed function, write the equation of the transformed function, and so clearly the equation of the transformed function can be written as, we have just right there, f of x is basically equal to minus within square root half of x plus 1 plus 3. this portion is within the square, right? So this is negative, right? So let me rewrite. So it is minus square root of half of x plus 1 plus 3. Correct? So that is how you get your transform function. So I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.